So this is going to be chapter 4, section 4 of geometry, which is about another set of basically shortcuts to proving triangles are congruent. So we talked about proving triangles congruent by definition, which is matching up all three sides with all three sides of the other triangle and all three angles with all three angles of the other triangle. And then we talked about the side, 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 and side, angle, side theorems in the last video. So this is going to introduce two more shortcuts. So again, last video was side, 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 and side, angle, side. This video is going to be about these two. ASA and AAS, angle side angle and angle angle side. Now these sound like they're the same thing almost because they both require two angles and a side. The key difference is where the side resides. So these three right here, if I circle them real quick here, these three theorems right here are often ones people get confused. So let me model those out real quick about what you're looking for. So if you're trying to prove two triangles are congruent, you have a side angle side case. This is what the last video was talking about when you have something like this. You have this side matching with this side. You have this side matching with that side. And then you have this angle matching with that angle. That would be a side angle side case because you have two matching sets of sides and you have the angle that's between them matching as well. And again, it doesn't necessarily have to be these two bottom sides. So it could be something like this as well. You could say, let's say you have this side matches with this side, and this side matches with that side, and then you have an angle here matching with the angle there. So this would also be a side angle side case. So technically speaking, where they are doesn't matter as long as you have them corresponding. So as long as you can match them up by proving that they're going to be congruent, then it's okay. So that's a side angle side case. An angle angle side case is when you have two angles and then one side that's not between the two angles. So an example, this angle here matching, this angle here, and this angle here matching. And then you say you have this side right here and this side right here matching. That'd be an angle angle side case because you have two sets of angles and then you have one side that's not between them also matching. So you have angle angle side. Angle side angle would be something like this. You have matching angle here, matching angle here. You have matching angle here, matching angle here. Whoops, matching angle there. And then you have this side right here in the middle. So this time you also have two angles on a side, but this side is in between the two angles, whereas this side is not. One way I can tell about this is if I do this on my proofs, I would label it as A, S. If I could draw a line between my two A's without crossing the S, then it's an angle angle side case. If I try to do that here, A, S. If I try to draw a line between my two A's, I end up crossing over that S. So if I can do it without crossing over the S, it's angle, angle, side. If I have to cross over the S, it's angle, side, angle. So those are our four shortcuts we have right now. If we want to prove triangles are congruent, instead of doing it by definition, we have these four shortcuts available to us to work with. So let's put these into practice here. So this is an example of one that's already done for us. It says, given that QS bisects PQR and that angle PSQ is congruent to angle RSQ, prove the two triangles here are congruent. So they start with their given. Then they say, okay, I hear the word bisector here. So I'm probably going to be using definition of a bisector as one of my reasonings here. So it says QS bisects PQR. Well, here's PQR. So that's this angle right here. So if it bisects that angle, that means the top half has to be congruent to the bottom half. That's what it means to bisect, to cut in half. So that's where they get this statement right here. PQS, which is this angle right here, is congruent to RQS, which is this angle right here, because of bisector, because it's got cut in half. So that gives them an angle that matches. It also says right here, PSQ is congruent to RSQ. So PSQ congruent to RSQ. So they have two angles here. So they said, okay, well, I have two sets of matching angles, and then they look at the reflexive side. So this QS, remember, is reflexive because it's in both triangles. So I'm going to mark it down here. It's reflexive. And therefore, they have an angle side angle case. They have one pair of matching angles. They have two pair of matching angles. And they have a pair of matching sides, which ends up being the same side. That's because it's in both triangles. And again, if I try to connect my A's, I cross over the S. So it's an angle side angle case. If I said, PQ was congruent to RQ instead, then it'd be an angle angle side case. So let's try one on our own here. Again, it says flow proof. We're just going to do two column because that's the standard form. So I'm going to be lazy with my given again here. So I'm going to write given. Okay. So let's mark up this picture here. Zx bisects WZY and XZ bisects W or YXW. So these two angles right here and here are bisected by this middle line. Well, the first thing I would do is actually say that, okay, I have the side XZ here, and that's going to be reflexive, right? Because it's in both triangles. Both triangles have a um, XZ and an XZ. So I'm going to say that XZ is congruent to XZ because of reflexive. Okay? So get that one out of the way, just so I don't forget it. Now I'm going to look at and say, okay, well, I have two bisectors here. So let me look at what angle's been cut in half and see if I can get the small pieces. So it says ZX bisects WZY. So WZY, so that's this angle right here. That gets cut in half there and there. So this angle right here would be WZX, so angle WZX would be congruent to the bottom half, which would be angle YZX. That would be one case of a bisector. So that'd be definition of bisector. Now, because I'm going to be using the same reason, I'm just going to do this on the same line. So it says XZ bisects YXW, which is this top angle here. So if XZ bisects YXW, which is this angle right here, that means the top part has to be congruent to the bottom part. So that'd be, let's see here, it'd be ZXW. So angle ZXW is congruent to angle ZXY. So those are both by definition of bisectors. And now I have a case where I can go ahead and do my proof statement. Congruent to YXZ. Because if I look here, let's see, I have a pair of matching angles, a matching side that's reflexive, and another pair of matching angles. So if I try to draw a line between my A's, I end up crossing over the S, so that'd be an angle side angle case. And again, you can always mark it on your proof too. You have a matching set of sides, you have a matching set of angles, and you have a matching set of angles. So you're going to be using either angle angle side or angle side angle because that's what you have to work with. And then you go to your picture to see how they're arranged and which one of those two fits. Obviously, it can't be side angle side or side 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 because if it was side side side, you'd have to have three sides, and we only have one. And if it was side angle side, you'd have to have two sides, but we only have one. This one got cut off. Let me see if I can't fix that. Let's try to shrink this down here a little bit and get it fitted in. There we go. Let's see if that makes it any better. There we go. So let's go ahead and write our two columns in here. Again, I'm just going to put a given there. Now, one thing to note is I can see right off the bat in my given that I'm given that I have two sets of parallel lines. That's what this symbol right here means, that these two lines are parallel. So if I have parallel lines, think back to last chapter, I have a few sets of angles I can do. I can do alternate interior, or I can do corresponding. Both these kinds of angles, remember, are congruent. So alternate interior and corresponding angles are congruent. So if I need some matching angles, that would be one thing to look for, is alternate interior or corresponding angles. Now, they can be kind of hard to see in a diagram like this, but one thing to know is that if you want alternate interior angles, these angles sort of form a Z pattern. So if you look at what I mean here, these are my two parallel lines, right? That's what these arrows mean, is that these lines are parallel. So that means that if I take one of these lines here, let me start at the bottom here. If I go up to R, then down to T, then up to S, that Z pattern, the corners of this Z, this right here and this right here, the corners of that Z are my alternate interior angles. So I could say that angle R is congruent to angle T by alternate interior angles. Angles theorem, if I want to be exact about it. And if you want to, you could do the other way as well. So if I really wanted to, just as a reference, I could do it the other way if I want to get the other set of alternate interior angles. I start at my two sets of parallel lines, so I pick one of the parallel lines to start on. Let's say this one right here, RQ. I go down to Q, I go up to S, and I go down to T. And that means that angle Q and angle S would also be alternate interior angles. So if you're looking for alternate interior angles because they tell you that two sets of lines are parallel, look for a Z pattern that you could kind of go off of and help guide you there. Now, the reason I'm not writing that one down is because I want to make sure I also know another type of angle that should be on our first to look for list, and that is vertical angles. So remember, vertical angles make that X pattern, and in this case, you have a set of vertical angles right here, that middle X shape there. So angle RUQ, this angle right here, is going to be congruent to angle SUT, this angle right here. So angle RUQ is going to be congruent to angle SUT by vertical angle theorem. Okay? So be on the lookout for vertical angles as well, because those should be kind of free. They're almost like reflexive. They're free information, free congruencies that you can use to help you set up an SSS, an SAS, or something like that. So let's take stock of what we have there. We have these two vertical angles congruent. We have angle R and angle T congruent based on alternate interior. And we have that RQ is congruent to ST because that was given to us. So if I look at this here, I have an angle set of matching, I have another angle set matching, and I have a side set matching. Now, I can draw a line between both my A's without ever crossing over that S. So in this case, I can go ahead and say that my triangles are proven congruent now, RUQ, congruent to TUS, but in this case it'd be angle, angle, side, because the side that I have that matches the side set is not in between my two angle pairs. It's on the outside of those two angle pairs because I can draw a line between my two angle pairs and not cross the S. Let's try one more here. So I'll draw my two columns here. Again, make that my given. All right. So we're given two bisectors. We're saying CB bisects both ABD and ACD. Well, if I hear the word bisects, that means I'm probably going to end up with two halves of something, right? But before I get into that even, first thing to look for, reflexive. So in this case, CB is reflexive because it's in both triangles. It's acting as the bridge or the fusion line between both triangles. So I'm going to write that down right away because I know that that's a free congruency. I don't really have to think much about doing that. I just know it because it's in between both triangles. So reflexive. And that gives me a free matching side. So all I need now is two angles, and I can do an angle, angle, side, or an angle, side, angle situation. And again, the reason I know that CB is reflexive is because if I look at my triangles, here I have BC, here I have CB. So I have the same two letters in the exact same arrangement in terms of, they're both the last two letters, even though they're in a different order. That means that it's going to be reflexive, in those cases at least. So CB bisects ABD. So here's ABD, that top right corner there, which means that the top part of that corner and the bottom part of that corner have to be equal. So that'd be angle, the top part would be ABC, congruent to angle CBD. Now it also says that it bisects the bottom left corner as well, ACD. So that means the top of this angle, ACB, and the bottom of that angle, DCB, would also be congruent. So ACB is congruent to DCB. And this is by definition of bisector. So now I look here and I'm going to write down what I have. I have two sets of matching angles. I have a set of matching sides, which is reflexive, and I have another set of matching angles. If I try to draw a line between them, I cross over the S. So now I can go ahead and say with confidence that my triangle ABC is congruent to triangle DCB by angle, side, angle. Okay? Again, if you have two angles in a side, it's going to be one of those two, angle, side, angle, or angle, angle, side. Okay? And always be on the lookout for reflexive and vertical angles. So reflexive and vertical angles should be the first thing that you write down and look for. Then you go to the bisectors and midpoints. Then you go to the alternate and corresponding if you have parallel lines. And then you go to other stuff if you need to. But usually by the time you get to there, you've gotten at least three things you need. Because remember, all these theorems, side, 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 angle, side, angle, and angle, angle, side, they all require just three things. So once you've gotten three things proven congruent, once you have your three congruencies, then take stock of what you have and see if you've matched any one of these here, because chances are you have. Let's do one more here. This one's a little more complicated because it just has parallel lines here, but we can do it. Making sure that's a given. Okay. Now, again, if you have parallel lines, what you should be on the lookout for is alternate interior, which is that Z pattern, or corresponding. Remember, corresponding are stuff that's in the same position. These are a little bit harder to see. So if you can't find alternate interior, chances are you're dealing with the corresponding, but always check to find alternate interiors first if you can. And again, you're looking for a Z pattern for alternate interior. But first, before any of that, as always, we look for reflexive, and I can see reflexive piece right here with JM. So is, JM is congruent to JM because of reflexive. So that's a side piece that I have matching. That's an S. Now I need my angles. Okay, so I have LJM I have LJ parallel to MJ, or MK. LJ parallel to MK. So I'm going to try to figure out if I can't get a Z pattern going on here. So if I take my pen, do this in, say, a darker green here, and I trace along this here. Let me do a different one because that doesn't look too good. Let's try this. If I trace along LJ down here and then go up MK. Again, the reason I'm going up these two lines is because they're the lines that are parallel. JL and KM are both parallel, so I have to go up both of those. And then I go across the transversal bridge, which is JM. And I have this Z pattern here, like I've been saying. So that means that this corner of the Z, angle LJM, is going to be congruent to this corner of the Z, angle JMK. So angle LJM is congruent to angle JMK by alternate interior angles. And then I can also do the Z pattern the other way with the other two sets of parallel lines. So if I want to, I have two other parallel lines here, KJ and ML. So I'm going to go down here, go down ML, go up the transversal, and then go down JK. And I have another Z pattern here with this corner of the Z, LMJ, congruent to this corner of the Z, MJK. So LMJ is congruent to MJK, also by alternate interior angles. So again, that Z pattern is how I'm identifying these alternate interior angles. I don't have any reflexive angles to work at, so I don't need to bother with those. But I do have three sets of congruencies here. I have a set of congruent sides, and I have two sets of congruent angles. So let me write them on the picture here and see if I can't figure out what type of congruency I can finish off with here. So I have a congruent side pair there. We have these two angles congruent, and we have these two angles congruent. So it looks like here I have an angle set matching, a set of sides matching, and another set of angle matching over here. And it looks like if I'm drawing a line here, I'm going to cross over my S. So this means that I'm going to have JML be congruent to MJK by angle side angle. So again, we're just kind of building up shortcuts so that we don't have to prove 6 different things in a proof here. And so we have options to go for rather than trying to have, everything be side, 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 or side, angle, side. So when you're doing a proof of trying to prove triangles are congruent, when you're trying to prove triangles are congruent, you want to look for one of these cases. Side, 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 get all 3 sides congruent. Side, angle, side, angle, or angle, angle, side. You're trying to get to one of these 4 situations. So look for reflexives first, verticals next. So reflexive and verticals are your first priority because those are free congruencies. Those are going to be like free starts on this here. Then after you get reflexive and verticals out of the way, look for, what did I say here? Oh, sorry. Reflexive and verticals first, and then look for bisectors and midpoints. So bisectors and midpoints will help you, again, get some congruencies there as well. Then once you've gone through bisectors and midpoints, then look for any alternate interior or corresponding angles that deal with these parallel lines here. So if you have a set of parallel lines, you want to be on the lookout for these as well after you've gone through your other 2 checks. And by the time you get done with that, you should have at least 3 things that are congruent, and you can start figuring out which one of these 4 cases that you have. So that's it for this video. Again, let me know if you have any questions. Hopefully helped you out, and then have a good day, night, or afternoon.